Hello everyone, welcome to eget.ai. In this video, let's talk about rational agents. So what is rational agents? So as I have written it down, a rational agent is an agent which always does the right thing. Okay. So what do we mean by doing the right things? So we have seen some examples of agents already. Doing right thing mean that given a particular percept sequence, what would be the right action to take? So for any agent, we have these four things. We have one environment, we have sensors, we have actuators. Okay, so agent should have some prior knowledge of the environment. What do we mean by prior knowledge? Like for the vacuum cleaner example, the prior knowledge for agent would be to know that there are only two blocks in the vacuum cleaner world, right? There was block A and block B. You can refer to my second video. In that we have discussed the example of vacuum cleaner world. So by prior knowledge, I mean having a knowledge that there are only two blocks available for cleaning, right? So this is the prior knowledge. What are the sensors? That means what is the percept sequence so far? Percept sequence so far. By actuators, it means what actions it can take. Okay. So now, given a prior knowledge of the environment, given the percept sequence, the agent will take some action. So how do we measure if the actions are right or wrong? For that, we will have something called as performance measure. Okay, so what is this performance measure? So performance measure can be anything, like for a vacuum cleaner world, the performance measure could be the amount of dust it can suck in 1 hour, or for a, like, say, self-driving car, the performance measure could be how fast the car can reach from source to destination, or how safe it is to reach from source to destination, or how much less fuel it will consume in order to reach from source A to destination B. Okay, so this performance measure evaluates environment. Okay, what was the environment in the beginning, and after say few percept sequence, what is the state of the environment? Okay, so these four factors are very important when we talk about rational agents. So now, since we have idea of all these four things, let's have a more standard definition of rational agents. This is the standard definition from the book Artificial Intelligence: A Modern Approach by Stuart Russell. This book we are following throughout this course. So basically this says that for every possible percept sequence, a rational agent should always select an action that is expected to maximize the performance measure given the percept sequence and built-in knowledge it has, right? So this formally explains everything that we were talking about. A very interesting thing to note here is that this is expected to maximize the performance measure. Okay, this is not absolute. Why this is not absolute? Because a rational agent can do right things, but it can only do right things based on the percept sequence it has seen so far and the built-in knowledge about the environment. It cannot look beyond the percept sequences and built-in knowledge. Okay, so given a percept sequence, given a built-in knowledge, it is expected to maximize the performance measure. So if the agent knows everything and it is taking the best action always, then we will call that rational agent to be a perfect rational agent. Okay, this is called perfect rationality. Okay, this is, I would say, impossible to achieve. Perfect rationality means an agent knows everything and it is taking the perfect action, the best action, to maximize the performance measure. So even human beings do not satisfy the definition of perfect rationality. So there is an idea of bounded rationality. So bounded rationality means, since say humans cannot see the whole environment, they don't know what will happen if they will take a particular action, although they want to take an action in order to achieve the goals, then we will call that as an bounded rationality. So when we talk about rational agents, rationality in AI, we are mostly talking about bounded rationality. Okay, perfect rationality is something which we call as omniscience. We call that as omniscience agent. Okay, this is like impossible to achieve because this omniscient agent means the agent knows what will be the outcome of its actions, so that it will take the best action every time in order to reach the goal or in order to maximize the performance measure. So in the beginning of the video we were talking about four things about an agent: the performance measure, sensors, actuators, and environment. So this actually called as task environment. So let me write it down. This is called, okay, so in acronym we can call as P.E.A.S. This is performance measure, this is environment, this is actuators, and this is sensors. Okay, so for any given agent we have to define this P.E.A.S property of the agent. To design any agent we have to first define what is the task environment for that agent. Okay, so for example we want to define task environment for self-driving car. So we have an agent called self-driving car. Okay, what would be the task environment for that agent? So for self-driving car the performance measure can be, say, how fast or how slow it reached to the destination, how safe it was, how legal it was, I mean whether the car was following traffic rules or not. And there can be other things like how comfortable the trip was, how much maximum profit it can give you. So these are the performance measure. The environment for self-driving car can be road, it can be traffic lights, traffic, it can be people, it can be pedestrian, anything. Okay, so you have to define all the possible environment for self-driving car. What are the actuators for self-driving car? These are, say, wheels, right, brakes, and so many by which you can do any action in the self-driving car. What are the sensors for self-driving car? It can be camera, sonar sensors, or say engine sensors and other kinds of sensor. So this is the piece description or task environment for self-driving car agent. Okay, so this is very important for gate. They might give you some agent and they might ask you to define what is task environment for this particular agent. Okay, so you have to think properly what could be performance measure in that case, what could be the environment, what could be the actuators, and what could be the sensor. So this is the task environment for any agent. Now let's understand this task environment in more detail because this is very important. So there can be several kind of environments, and let's try to understand all the possible kinds of environments. Okay, so the first environment can be categorized by observability. So based on observability, the environment can be fully observable or it can be partial observable. Okay, so what do we mean by fully observable environment? So fully observable environment is an environment where sensors can sense the complete state of environment. Okay, so in chess playing agent, the agent will have the knowledge of complete chessboard, right? So that is an example of fully observable environment. And in partial, it cannot sense the complete state of environments because of some limitations, because of noise. For example, say talk about vacuum cleaner world, right? So the sensor which can sense if there is dirt is a local sensor. It cannot sense if there is some dirt in another block, right? It can only sense the dirt in the local block. So in most of the cases our task environment is partially observable, and if it cannot observe the environment at all we call that unobservable environment. Okay, we can categorize task environment based on determinism. Okay, so environment can be deterministic or it can be stochastic. So in deterministic environment, the next state of the environment can be completely determined given the current state and the action that agent is going to take. Okay, this is something called as deterministic environment. And if the next state of environment is uncertain, then the environment will be stochastic environment. Okay, so the example of deterministic is say image analysis, in which if you have done certain kind of analysis, then that will be next state of the environment. But in stochastic, say let's take example of Ludo, right? So in Ludo, the you cannot determine by taking in the current state and taking the current action what would be the next state of the environment, right? So then the environment is stochastic environment. So one interesting thing to note here is that so partially observable environments may look stochastic to the agent, because since the agent cannot see the whole environment, it cannot be very sure that by taking a particular action what would be the next state of the environment. Another category can be based on episodicity. Okay, so again, based on this, there are two categories of environments. One is episodic, another is sequential. So in episodic environment, say the experience of agent is divided into episodes, like given a particular state, given a particular percept sequence, this is the action it has to take. Okay, so for episodic environments, one of the example can be say classification task. If the agent has to classify whether say in an assembly line some particular part is defective or not, so this is episodic. In this case, agent does not have to look in the past whether the previous part was defective or not, right? Whereas in sequential environment, agent have to think ahead because all the episodes are connected. So for example, a chess playing agent, right? So in chess, all the moves are sequential, right? You have to plan ahead before taking any moves, right? So this is an example of sequential environment. So another category of task environment is based on dynamism. Okay, so an environment can be static or it can be dynamic. Okay, so in static environment, the environment should not change while say agent is thinking. So for example, if the agent is to solve a crossword puzzle, right? So if you are the only agent solving a crossword puzzle, environment will not change unless you enter the word in it. So that is an example of static environment. If the environment changes while the agent is thinking, then the agent is dynamic environment. Of course, the self-driving cars are example of dynamic environment, because if the car is moving on the road, the other cars are also moving, right? So while it will take any action, the environment will change for sure, right? So that is an example of dynamic environment. One thing to note here is that so even if the environment does not change with time, but the performance score for a particular thing might change while it is thinking. For example, for self-driving car, say the environment is not changing, there is no cars in the road and you have the complete free road from say source A to destination B, but if it is taking too long to think what actions to take, then the performance measure, where we are measuring how fast the car can reach to the destination, will be affected, right? In that case, we call the environment to be semi-dynamic. Okay, so in semi-dynamic environment will not change while agent is thinking, but it will affect the performance measure. Okay, another category of environment is based on continuity. So based on continuity, there can be two categories. One is discrete environment and other is continuous environment. So by discrete, we mean that the number of percepts the number of states of environments are limited, then we call the environment as discrete environment, right? And if the state of environment is unlimited, so self-driving cars operates in a continuous environment because the number of states of the environments are continuous, because there are other cars on the road, there will be other people on the road, so you cannot count how many states it has to go through, right? So in that case, the environment is a continuous environment. So one final category of environments is based on the number of agents. So if there is just one agent, single agent environment, and if there are more than one agents, we call it multi-agent environment. Okay, for example, let's take an example of chess playing game, right? So there will be two agents playing the game. So in that case, the agent have to also consider the actions that other agents will take, right? So that is a multi-agent environment. So you have seen that there are several kinds of task environments that we can categorize based on certain things. So we have covered a lot of theory in this video, but you do not have to worry. We will provide some short notes in which we will summarize the idea of task environment and what are the different kinds of task environment, which you can refer after this video. All right. So till now, we haven't talked about the agent program, right? So in the next video, we will discuss what is agent program and how we can write different kinds of agent program. All right. Thank you so much.